Good day everyone, I am your reporter Rizes Talioso and my topic is all about the temperature, geographic distribution, time variation, and measurement. Distribution of temperature. Distribution of temperature varies both horizontally and vertically. Let's study it under letter A, horizontal distribution of temperature, and B is the vertical distribution of temperature. In horizontal distribution of temperature, number 1 is the distribution of temperature across the latitudes over the surfaces of the Earth is called its horizontal distribution. Number 2, on the maps, the horizontal distribution of temperature is commonly shown by isotherms. Number 3 is isotherms are the line connecting points that have an equal temperature. Number 4, when we analyze an isotherm map, it can be seen that the horizontal distribution of temperature is uneven. So it is shown in the picture which is the lines. So that karat na mga lines is muna siyang ginatawag na isotherms which is naga-show sa distribution of temperature across sa latitudes. So on the next slide is the factors responsible for the uneven horizontal distribution of temperature are number 1, the latitude, number 2, altitude, number 3, land and sea contrast, number 4, ocean currents, number 5, air masses, and number 6 is the vegetation cover. So, number 1 is ang latitude. Higher the angle of incidence, higher is the temperature. Similarly, lower the angle of incidence, lower is the temperature. This is why the temperature is higher near the tropical regions and decreases towards the poles. So, as shown in the picture, karang mga red lines sa globe, mauna siya ang ginatawag na latitude. So, it means when it comes to temperature, the higher the angle of the incidence kay the higher pud ang temperature, and if lower ang angle of incidence kay lower pud ang temperature. And the next is ang altitude. The temperature in the troposphere goes on decreasing with increase in height, and the temperature decreases at an average rate of nearly 6 degrees Celsius per 100-meter altitude, which is known as normal lapse rate. So, ang altitude is muna siya ang vertical lines na makita ninyo sa globe. So, muna siya sa picture ang mga naka-red lines. So, it means na kapag ang temperature kay naga-decrease kay ang height is increasing. And ang normal na lapse rate is normal or average is 6 degrees Celsius per 1,000-meter altitude. And then, ang next, number 3 is the land and sea contrast. Compared to land and sea gets heated slowly and loses heat slowly. Land heats up and cools down quickly. As a result, the temperature is relatively higher on land during daytime and is it higher in water during the night. Also, the places situated near the sea come under the moderating influence of the sea and land breezes which moderates the temperature. There are also seasonal variations in the temperature of land and sea. During summer, the air above land has a higher temperature than the oceans, but the air above oceans gets higher temperature than landmass in winter. Notwithstanding the great contrast between land and water surfaces, there are differences in the rate of heating of different land surfaces. A snow-covered land is in polar areas warms very slowly because of large amount of reflection of solar energy. A vegetation-covered land does not get excessively heated because a great amount of insulation is used in evaporating water from the plants. So sa land and sea contrast kay mas mas mabalaan man jud nato na ang land is karang mag-heat siya or mag-cools down siya very quickly than sa water or sa sea. So, it is also stated nga na ay mga places which has a vegetation cover or karang mga maka-experience og snow kay they can have karang small amount of heat na madawat kaysa sa iba na vegetation or kaysa sa iba na mga places. Ocean currents. Ocean currents are the two types, warm and the cold. Warm currents make the coast along which they flow warmer, while cold currents reduce the temperature of the coast along which they flow. And the northwestern European coast do not freeze in winter due to the effect of North Atlantic drift, or a warm current, while the Quebec on the coast of Canada is frozen due to the cold Labrador current flowing along it, though the Quebec is situated in lower latitudes than the northwest European coast. So, understandable naman na ang ocean currents kay na ay two types, ang warm and cold. So, ang warm kay give a warmer flow, and the cold is they give the colder, or they reduce the temperature of the coast along which they flow. So, ang pinaka example nila is ang Quebec, or as in the picture, ang Quebec is geographically placed na na ay cold Labrador current, or placed in a lower latitude, is which means they can experience na mga snow and cold breeze or cold weather. So, number 5 is the air masses. Like the land and the sea breeze, the passage of air masses also affects the temperature. The places which come under the influence of warm air masses experience higher temperature, and the places that comes under the influence of cold air masses experience low temperature. So, as shown in the picture is the different kinds of air masses. So, MT means the maritime polar, MT means the maritime tropical, or the warm or the moist kinds of air masses. Next is the CT, or the continental tropical, which has a hot or dry air, and CA, the continental Arctic, very cold and dry, and CP is the continental polar, which they can experience cold and dry air. Number 6 is the vegetation cover. Soil devoid of vegetation cover receives heat more rapidly than the soil under vegetation cover, because vegetation cover absorbs much of sun's heat and then prevents quick radiation from the earth, whereas the former radiates it more rapidly. Hence, the temperature variations in densely forested areas are lower than those in desert areas. The horizontal distribution of temperature over the globe can be studied easily from the isotherm maps of January and July months, since the seasonal extremes of high and low temperatures are most obvious in both northern and southern hemisphere during these months. So there are different kinds of vegetation cover. So around the globe, it depends if what kind of temperature can you feel, whether high or low. It depends on the vegetation cover of the place you are in. And number one example for vegetation cover is the steppe in Kazakhstan. So this kind of vegetation cover is a large area of flat, unforested grassland in southeastern Europe or Siberia. The next is the taiga in North America, or a forest of the cold subarctic region. The next is the prairies, or the flat temperate grasslands found in the North America. Next is the tundra, which is the type of biome where the tree growth is hindered by low temperatures and short growing seasons. Savanna, or a mixed woodland grassland ecosystem characterized by the trees being sufficiently widely spaced so that the canopy does not close. Then last is the rainforest, which is characterized by a closed and continuous tree canopy, moisture dependent vegetation, the presence of epiphytes and lianas, and the absence of wildfire. So in the next slide is the horizontal distribution of temperature in January. In January, the sun shines vertically overhead near the Tropic of Capricorn. Hence, it is summer in southern hemisphere and winter in the northern hemisphere. A high temperature is found over the land masses, mainly in the three regions of the southern hemisphere. These regions are northwest Argentina, east and central Africa, and central Australia. Isotherm of 30 degrees Celsius closes them. In the northern hemisphere, land masses are cooler than the oceans. As the air is warmer over the oceans than over land masses in the northern hemisphere, the isotherms bend toward the north poles when they cross the oceans and to the south or equator over the continents. This can be clearly visible over the North Atlantic Oceans, the presence of water oceans current, or the Gulf Stream and North Atlantic Drift, make the North Atlantic Ocean warmer and the isotherms bend towards the poles. Over the land, the temperature decreases sharply and the isotherms bend towards the equator in Europe. In southern hemisphere, the effect of the oceans is well pronounced due to few land masses. Here, the isotherms are more or less parallel to the latitudes, and all the variations in the temperature is more gradual than in the northern hemisphere. So, as said earlier, during the month of January, summer can be experienced in the southern hemisphere and winter can be experienced in the northern hemisphere. And the high temperature can be found over the three main regions which is located on the southern hemisphere. Next is the horizontal distribution of temperature in July. In July, the sun shines vertically overhead near the Tropic of Cancer. Hence, high temperatures are found in the entire northern hemisphere. The regions having high temperature include southwestern USA, the Sahara, the Arabia, Iraq, Iran, Afghanistan, desert region of India, and China. However, the lowest temperature of 0 degrees Celsius is also noticed in the northern hemisphere during summer in the central part of Greenland. During summer in the northern hemisphere, isotherms bend towards the equator while crossing oceans, and towards the poles while crossing land masses. Isotherms are wide spaced over oceans while they are closely spaced over land masses. In July, the deviation of isotherms is not that much pronounced as January. So compared horizontal distribution of temperature during July in January kay which is ano siya, near the Tropic of Capricorn. So ang horizontal distribution of temperature in July kay overhead near on the Tropic of Cancer. So ang high temperatures na sad kay can be found sa northern hemisphere. So, unlike sa January which has only three regions na kabilang under sa southern hemisphere, sa temperature in July, kay there are lots of regions which can experience high temperature in the northern hemisphere. So let us proceed to the second distribution of temperature, which is the vertical distribution of temperature. So number one is the temperature in the troposphere decreases with an increase in the altitude. Number two, this is the vertical gradient of temperature is commonly referred to as a standard atmosphere or normal lapse rate. Number three, however, this normal lapse rate varies with height, season, latitude, and other factors. Number four, indeed, the actual lapse rate of temperature does not always show a decrease with altitude. So, the lapse rate actually tells the rate at which temperature changes with the height in the atmosphere. So, for example, the karang which is shown in the picture. So, the normal lapse rate temperature is 3.6 degrees Fahrenheit per 1,000 feet. Next slide is the inversion of temperature. The phenomenon in which temperature increases with the increasing altitude temporarily and locally under certain conditions is known as the inversion of temperature. So inversion is usually a short duration but quite common nonetheless. Long winter night, clear sky, dry air, and absence of winds leads to quick radiation of heat from the Earth's surface as well as from the lower layers of the atmosphere. So, as shown in the picture is kung paano ang isa ka thermal inversion nag-process. And also, kung unsa ang normal pattern sa isa ka inversion of temperature. So, ang normal pattern is came from the warm air cool air hangtod sa cooler air when it rises up, while ang thermal inversion kay ang kabaligtaran sa normal pattern. So this usually happens when the normal heat gradient of the atmosphere is reversed. During this kind of inversion, kay ang cold air kay na-trap siya beneath sa warm air, creating a pocket of stagnated or stagnant na air close to the Earth's surface. Mao na siya ang shown in the picture kay di ba ang iyahang arrow kay nagabalik lang Japan, which is na-trap siya inside. This results in the cooling of air near the Earth's surface. The upper layers, which lose their heat not so quickly, are comparatively warm. Hence, the normal condition in which the temperature decreases with increasing height is reversed. The cooler air is the nearer to the Earth and the warmer air is aloft. In other words, temperature increases with increasing height temporarily or locally. The phenomenon of inversion of temperature is mostly observed in intermontane valleys due to air drainage. During winters, the mountain slopes cool very rapidly due to the quick radiation of heat. So the air resting above them also becomes cold and its density increases. Hence, it moves down the slopes and settles down in the valleys. This air pushes the comparatively warmer air of valleys upwards and leads to the phenomenon of inversion of temperature. Sometimes the temperature falls below freezing point in the valleys, leading even to the occurrence of frost. In contrast, the higher slopes remain comparatively warmer, and this movement of heavy and dense cold air towards valley slopes, almost like water, is termed as air drainage. So, as what I have said kaganina or ako gi-explain kaganina, mao to siya. That is the end of my report. Thank you for listening.